Hi friends, in this video let us solve a similar system related question asked in GATE 2004 EC paper. The question is, a causal LTI system is described by the difference equation 2y of n is equal to alpha y of n minus 2 minus 2x of n plus beta x of n minus 1. The system is stable when, right? So to find whether the system is stable or not, first we find h of z. Right, so we have to find h of z. H of z, if you want to find h of z, we have to take Fourier transform. So z transform. So z transform of given system, right? So given system is 2 into y of z equal to alpha for y of n minus 2. Z transform is z power minus 2 y of z minus 2 into x of z plus beta z power minus 1 x of z. Right, so if you find h of z, which is nothing but y of z divided by x of z, if you simplify this, what you get is beta z power minus 1 minus 2 divided by 2 minus alpha z power minus 2. So I remove all the minus power, make it plus. So if I take z outside, so beta by 2, I take 2 also outside, minus 1 divided by z square minus alpha by 2. I take z inverse and the z2 outside, so I have taken this. If I take 2 outside, it will be beta by 2, z power minus 1 I have taken. So in denominator I have taken 2 and z power minus 2. So if you simplify, I will get this. Okay, so after that, what is the thing? This is h of z. When a system is stable, for a system to be stable, poles must be inside a unit circle. That's what we know in LTI system, right? So what is the pole here? Here pole is z is equal to root of alpha by 2. So as per the condition, this is pole. So pole must be inside the unit circle. So root of z by magnitude of the pole must be less than 1, right? So if you simplify, what you get is root alpha is equal to root 2. So the alpha is less than 2. What about beta? Beta is nothing but a 0. So beta may be anywhere. So beta may be anything. So alpha must be less than 2 and beta must be anything. Right? So alpha must be answer C is the right answer. Alpha must be less than 2. Beta may be anything. Thank you.